Okay. All right, so what I'm going to do today is I'm going to approach the same problem of the area between two curves, but I'm just going to show you a different way to look at it. Okay, so what I've done here is I've got an area, and I'm labeling this with two different functions. We'll just call it f and g, and then I'm going to identify the region that I'm going to try to find. So if you can imagine this, okay, everybody see it? Okay, so you see the region, okay? All right, now, what do you do when you have 5,000 sipper stirrers? Okay. Okay. I used to be in charge of the coffee for all the teachers, so I bought these sipper stirrers. It was a really good deal at Sam's Club. The problem is, I got 5,000 of them, and they've used about 100. So these bags were sitting here, and I had this revelation when I was eating lunch one day. Hey, this would be a perfect way to explain how to do the area between two curves. So what I did was I made these regions, but you see what I made them with? I took the sipper stirrers, and I taped them. See that? And then I cut them. Okay. So you can see what I did? Okay, so they're taped on the back. So I made the region, okay, but it's a magical reason. And I fixed it. That's right. Okay. Now, the purpose in it is in the fact that with the sipper stirrers, I can actually demonstrate the whole point about the Riemann sums, that it's actually a sequence of rectangles, where I should have counted them, but there's probably like 40 of them across here. Okay? Okay? Imagine each of these being a rectangle. Okay? With those being a rectangle, and I want to find the area, does everybody agree that the length of any random segment, I'll just draw a random segment here, the length of this segment, okay, if I say how long is that segment, how would you find that out? For any given x value, if you take the top functional value, minus the bottom one, you get that. So in other words, this is f of x minus g of x for that given x. Okay? And so I thought about this, and I said, well, what if I made a duplicate of this, but then I made it flat? In other words, I got to do this right. This is always hard to do this. Okay. So what I did was I took all the stirrers and I pressed them down. Those thingies, okay? And all I did was push them up from the bottom. So I had made an exact duplicate of the first one. Okay? And then I pushed them all up here so it's flat. Okay? Which means that the one on the end, you can see that's the same length. This one, let's see if it's the same length. So what we need is a really big caliper. Okay? So this is, except it's made it a little bit too big. We're off by that much, okay? So just remember that we're off by that much. So I take that and I move it down here. See how we're off by that much? Pay no attention to that one. Okay, let's do a different one. Let's do a different one. So remember this one? It was between here and here. Okay, see that? Between there and there. That's how long that strip is. If I go straight down, you see that? That's the height. It's the same height, okay? Because it's the same straw, but I just lined them up so the bottoms are all the same. Okay, we could do it for any other one. Let's pick another random one here. So we go from here to here. Okay, so it's this length right here. Okay, and I'll lock that into place here. And if I bring that down, there it is. See that? Okay, so every one of the straws is that. So when you're thinking about the area between the two curves, what I want you to imagine is, well, if you just were to just pile them all down, you would get that. You would get that area. But even though the area looks different, it's the same exact area. It's two regions that have exactly the same area, even though the shapes look different. I think the easiest one to explain is like my sidewalk. Okay. This right here, okay, if I were to do the same thing, if I made this out of stir sticks, I just push these all up, then what would happen is it would be a rectangle where they'd all be the same height. Understand what I'm saying? Okay, so it's a different way to imagine it. It's just that the distance between any one of these is equal to the distance here for any given spot. Okay. All right, so we went through several examples yesterday, and I'm going to have you do a problem in class today. And then I'm not going to talk about areas between curves anymore, between two curves, until Monday when the assignment is due. Okay, come on up here, pick up your worksheet. I want you to do this right now in class.
Should I just grab a big pile?
Yes. A pile of four.
Four?
And if anybody's artsy and craftsy and wants to make a sipper stir one, you can grab a handful and you can make one. I've got a vast quantity of sipper stirs. I know. Okay. All right, go ahead and do that right now.